Hello students, welcome back. I am Rinkesh sir and our today's topic is gravitational potential and gravitational potential energy near the surface of the earth. First, let's see what is gravitational potential. The work done in bringing a unit mass, see a unit mass from infinity to a given point in gravitational field against the gravitational field is defined as the gravitational potential. Okay, here in figure, consider this sphere as Earth, where me is the mass of the Earth. Now, work done in bringing a unit mass. That is the reason here m is equal to 1. A mass is taken as 1. So, bringing this unit mass from infinity to a point in the gravitational field, that is defined as gravitational potential at that point. Here, the unit of gravitational potential is joule per kg. Okay, and its dimensional formula is m0 L2 T minus 2. Remember that the work done in bringing a unit mass from infinity to a given point in gravitational field against the gravitational field is defined as gravitational potential at that point. Okay, now let's derive the formula for gravitational potential. Okay, let's consider the same figure. Here the mass is m, that is equal to 1 because it is unit mass. The mass of earth is m. The force acting on this mass, force acting on unit mass at P, position vector I will say R, that will be equal to, the formula for gravitational force is gm1 m2 by r square. So it will be gm1, that is mass of earth, and E. m2, that is the mass of this object, and that is unit. So I can write down 1, okay, upon r square. So this will be equal to gme by r square. So the force acting on this unit mass will be equal to gme upon r square. Okay. Now, if I just make displace this mass for a very small displacement, okay, if I, let's say the work done in displacing or moving the charge, sorry, not charge, it's mass, in moving the mass, in moving the mass, let's say by small displacement dr, small displacement dr, let's take, we are taking a small displacement in this direction, we move this by a small displacement dr in that direction. So the small amount of work done, let's take dw because we are only taking a small step. So it will be force into displacement F dot d. Here will be F dot dr. Here it will be F dr in vector form. It will be, so this will be F dr. Now see the direction of force. Okay, that will be in this way. And dr opposite, so angle makes 180. Okay, so I am writing that down F dot dr. That will become F dr cos theta, and as both are in same direction, okay, opposite direction, it will be equal to minus. So minus F dot dr. Why minus? Minus sign will be because, see, as you are moving away, it is this direction and the force is in this direction. So angle is 180, so it will be F dr cos 180. Value of cos 180 is minus 1. So this will be equal to minus gme upon r square into dr. So this will be the small amount of work done. So the total work done W will be integration of dW. So from R to infinity, we are taking the reverse case, means because we are moving the charge from this point to infinity. So from R to infinity, okay, so that will be equal to R to infinity minus gme by r square dr. Gme is constant. Integration of 1 by r square, that is minus 1 by r from r to infinity. Clear? So minus gme, once we will put the value minus 1 by infinity, that will be 0 minus minus 1 by r. This will be plus 1 by r and minus. So the total work done, that will be equal to the gravitational potential, and that is equal to minus gme by r. So the gravitational potential at any point which is the distance r from the center of the earth will be equal to minus gme by r. Clear? So remember, what is gravitational potential? Work done in bringing a unit mass from infinity to a given point in gravitational field against the gravitational field, that is defined as gravitational potential. Okay, say if the body or object is on surface of the earth, when we are moving it away, then we require energy against the gravitational field. Okay, so that work done is stored in the form of potential energy. So our next topic is potential energy, gravitational potential energy. Okay, now what is gravitational potential energy? Gravitational potential energy is the work done in bringing an object of mass m. Say in gravitational potential we were taking unit mass, but here it's object of mass m from, from infinity to a given point in gravitational field is defined as gravitational potential energy. So see, gravitational potential work done in bringing unit charge. So the work done in bringing, work done in bringing a unit mass. So the work done in bringing a mass of m, it will be multiplied by m. So gravitational potential energy will be equal to minus gmem upon r. Okay, work done in bringing a mass m from infinity to a point in gravitational field is defined as the gravitational potential energy of the combined system, okay, of the object and the earth at that point. Okay, so instead of earth, if two masses m1 and m2 are given, okay, imagine that there is no gravitational field existing of the earth. Okay, two masses m1 and m2 existing in space, then the gravitational potential energy between that two masses will be minus g m1 m2 upon r. Okay, clear? So this was about gravitational potential energy. Yeah, so this was about gravitational potential and gravitational potential energy. So just note down this topic. This is for, you can write down, in absence of gravitational field due to Earth. Okay, students, so that's it for today. Thank you.